Hello there. Hello there, fourth and fifth graders. Welcome to your next math lesson. Today's math lesson is called Compare and Order Fractions. So please open up your math notebook, turn to the next available page, and write that title at the top. Compare and Order Fractions. Okay, so today we're going to be comparing fractions, which means telling which fraction is bigger and which fraction is smaller, or seeing if they're equal. And then we'll be ordering fractions, which means putting them in order from either least to greatest or greatest to least, okay? Let's start with an example. Let's say we have 4/5 and 5/6, and we want to tell which fraction's bigger. So between these two fractions, we're either going to write greater than, less than, or equal to. Here's how you tell which fraction's bigger. First of all, what makes it tough to decide which fraction's bigger? It's the fact that the denominators aren't the same, which means these pieces, the numerator, aren't the same size. Like if you went with your friend to get pizza, and your pizza came cut into 5 slices, and you ate all but 1 slice, and your friend's pizza came cut into 6 slices, and he ate all but 1 slice, you can't just compare your 4 slices that you ate to his 5 slices, because your slices are bigger than his, because your pizza's cut into less slices. So you can't just compare these to say who ate more pizza. Like, oh, I ate 5 pieces, you only ate 4, therefore I ate more pizza than you. It doesn't work like that because the denominators aren't the same, so you're not comparing pieces that are the same size. So before we compare these fractions, we have to make the denominators the same. In other words, we need to make equivalent fractions. We're going to make a fraction right here and a fraction right here off to the side of these fractions. They're going to have the same denominator. This one will be equivalent to this one. This one will be equivalent to this one, but their denominators will be the same, so we'll be able to compare them. Okay, here's how we do that. First of all, you take both denominators and you list the multiples for both denominators until you find a number that's in both lists. In other words, you're looking for the least common multiple, also called the LCM. So you just count by 5s and you count by 6s until you find the first multiple that both 5 and 6 have in common. That's their smallest or least common multiple. So we count by 5s. 5, 10, 15, 20, 25, 30. Notice that's my 6th multiple of 5. Since it's my 6th multiple of 5, I know it's also the answer to 5 times 6, which means 6 is a factor of 30, which means 30 will also be a multiple of 6. So once I get there, I know I can stop. And then I count by 6s. 6, 12, 18, 24, 30. And so now I've got to a number that's in both lists, so I don't need to list multiples anymore. 30 is the least common multiple for 5 and 6. And in other words, it's the smallest multiple that both 5 and 6 have in common. Another way of saying that, it's the first number you reach when you count by 5s and when you count by 6s that's in both lists. So I'm going to make 30 my new denominator for both fractions. Now I know what my denominator is going to be for both of my new fractions, but how do I find out what my numerator will be? Here's what you do. You multiply from the old denominator to the new denominator. So you think, what would I have to multiply by 6 to get to 30? Well, that's 5. And then, this part's really important, whatever you do to the bottom, you have to do to the top. So since I multiplied 5 by the denominator, I have to multiply 5 by the numerator too, and 5 times 5 is 25. Okay? Now, I do that same thing over here. I multiply from my old denominator to my new denominator. What times 5 equals 30? It's 6. 5 times 6 is 30. And then whatever I do to the bottom, I have to do to the top. I multiplied 6 by the denominator, so I have to multiply 6 by the numerator too. And 4 times 6 is 24. So which fraction's bigger? 5/6 is slightly bigger than 4/5, barely, because if both pizzas were cut in 30 slices, this person ate the equivalent of 25 out of 30 slices, but this person ate the equivalent of 24 out of 30 slices. So in other words, 25/30ths is an equivalent fraction to 5/6, and 24/30ths is an equivalent fraction to 4/5. But now we can compare them because they're both out of 30ths. They both have the same denominator. So now these pieces that it's cut into, the numerators, can now be compared because we're now comparing slices that are the same size. So now we can just see which numerator is bigger. Since 25 is bigger than 24, that means this is the bigger fraction. So 5/6 is bigger than 4/5. Let's do another example. Let's say we have to compare 2/3 and let's do 5/9. Okay, we have to compare 2/3 to 5/9. We have to see which one's bigger. Well, remember, we take both denominators and we list the multiples for both denominators. That means we count by both denominators until we find a number that's in both lists. So we count by threes, 3, 6, 9. Notice, in counting by threes, the third number that we get to, 9, is the other denominator. So we know we can stop because the first multiple of 9 is 9. So we already found the least common multiple. It's the smallest number that's a multiple of both 3 and 9. That number is 9 itself. So in this case, we don't need to make an equivalent fraction for 5/9. It already has the least common multiple as its denominator. But we will make a new fraction next to 2/3. We'll make an equivalent fraction to 2/3 that also has 9 as its denominator. And that way we can compare this fraction to another fraction that's a like fraction that also has 9 as its denominator. Now, how do we find out what our numerator is? We multiply from the old denominator to the new denominator. What times 3 equals 9? 3 times 3 equals 9. And then whatever we do to the bottom, we have to do to the top. 2 times 3 equals 6. So 2/3 is equivalent to 6/9, which is bigger than 5/9. Therefore, 2/3 is bigger than 5/9. Okay, hopefully that makes sense to you guys. Again, how do you compare fractions? You simply make new fractions off to the side of the old fractions that have the same denominator. You make equivalent fractions. And the way you find that common denominator is you list the multiples for both denominators of the fraction until you find a number that's in both lists. And that's going to be your new denominator for both fractions. Then you multiply from the old denominator to the new denominator, and whatever you do to the bottom, you do to the top. Then you're comparing like fractions, which is easy because whichever one has a bigger numerator, when the denominators are the same, whichever fraction has a bigger numerator is the bigger fraction. Let's do another example. Let's say we have to compare 4/7 to 2/6. Now, in this case, there's something I want to show you guys. Sometimes you don't have to make common denominators because sometimes you can use what's called benchmark fractions. There's some really important benchmark fractions. We're going to call that BM, benchmark fractions. What are those benchmark fractions? 1/4 is a really important benchmark fraction. Also, 1/2 is a really important benchmark fraction, and 3/4. These are the three most important benchmark fractions. And you can use these to compare fractions. For instance, 4/7. Ask yourself, is 4 more than half of 7? Yeah, because 3.5 would be half of 7. And 4 is half of 8, which is a bigger number than 7. So that means 4 is more than half of 7. So that means 4/7 has to be bigger than this benchmark fraction, 1/2. Is 2 more than half of 6? No, 2 is less than half of 6 because 3 is exactly half of 6. So since 2 is less than half of 6, 2/6 has to be less than 1/2. So we just discovered without having to find common denominators at all, just using these benchmark fractions, that 4/7, since it's bigger than 1/2, has to be bigger than 2/6, which is smaller than 1/2. So we go like that. 4/7 is bigger than 2/6. Now, if we weren't sure how to use benchmark fractions, or if we weren't sure if we could always do it the other way too. We put the 7 here, we put the 6 here, we count by 7s and we count by 6s until we find a number that's in both lists. Hold that thought. Guys, I'm in the middle of recording a video right now, unfortunately, so I'm going to let you come in and grab it, but then just go right back out, okay? So we count by 7s and we count by 6s until we find a number that's in both lists. When you leave, can you go out the other door? Thanks. So 7, then the next one is 14, then after that it's 21, then after that it's 28, then after that it's 35, after 35 it's 42. Notice that's 1, 2, 3, 4, 5, 6 multiples we've listed for 7. So we know 42 will have to be a common multiple for 6 as well, since it's the answer to 7 times 6. Now we count by 6s, 6, 12, 18, 24. After 24 is 30. Sorry, just having a brain malfunction there for a second because I got too much going on in here because I have people coming in and out. That makes it hard for me to think. After 30 is 36, and after 36 is 42. So the first number we found that's in both lists is 42. So we're going to change both denominators to 42. Now we multiply from the old denominator to the new denominator. 6 times 7 is 42. Whatever we do to the bottom, we do to the top. 2 times 7 is 14. 7 times 6 is 42. And whatever we do to the bottom, we do to the top. 4 times 6 is 24. Since 24 over 42 is bigger than 14 over 42, 4/7 is bigger than 2/6. But again, we could tell that in this case without having to find common denominators, just using benchmark fractions. So it's important to have those benchmark fractions down. There's another important benchmark fraction, and it's called a whole fraction. Let's say it said 4/4. That just equals 1. It doesn't matter what the number is for the numerator and the denominator. If the numerator and the denominator are the same number, the fraction equals 1. So you can use that too. Let's say you had to compare 7/7 to 6/8. We already know this fraction has to be bigger because 6/8 is less than 1, and 7/7, since the numerator and denominator are exactly the same, 7/7 has to be more than 1. Okay, so that's how you can compare fractions. Now what about ordering fractions? Let's box this off and do some more examples. Let's say we had 1/7 and we had 4/5 and we had 6/6 and we had 3/5. Okay, how do we put these fractions in order from least to greatest? Well, first of all, we can use benchmark fractions. Remember, 1/4, 1/2, 3/4. Those are benchmark fractions. Which of these fractions do we know without even having to make common denominators? Which of these fractions do we know for sure is the biggest? Obviously 6/6 because it's 1 whole. So 6/6 is the biggest fraction. So we're going to put it all the way on the right. Which of them do we know for sure is the smallest? Well, 4 is exactly half of 5. And 4 isn't exactly. 4 is more than half of 5 is what I meant to say. And 3 is also more than half of 5. So both of these fractions are above 1/2. But 1 is much less than half of 7. So 1/7 has to be less than 1/2. So 1/7 is going to go all the way to the left. And now these two fractions are actually easy to compare because they already have common denominators. Since they both have 5 as their denominator, we can just compare the numerators. Since 3 is less than 4, 3/5 is smaller than 4/5, and 4/5 is bigger than 3/5, but obviously less than 6/6. And since I wrote it so far over here, I'm just going to write it here instead. So that's how we would put those fractions in order from least to greatest. Let's do one more example of that. I'll do it on the back side of the page because I kind of ran out of room. Let's say we had to order 1/9 and we had to order 5/6 and also 1/2 and 2/3. Okay, so which of these fractions do we know for sure is the smallest? Well, we have 2/3 here. 2 is more than half of 3. We have 5/6 here. 5 is more than half of 6. We have exactly 1/2, so that one should be close to the middle. And then we have 1/9. Is 1 less than half of 9? Yes. So that means that has to be the smallest fraction. Okay? Now, the next one, since 2/3 is more than 1/2, and since 5/6 is also more than 1/2, the next fraction has to be 1/2. Now we're just comparing 2/3 and 5/6. So let's list the multiples of 6 and 3. Oops, sorry, you can't see it. We're going to list the multiples of 6 and 3. The first multiple of 6 is 6. Since I already know 6 is a multiple of 3, I'm not going to keep going. The first multiple of 3 is 3, and the second multiple of 3 is 6. So the least common multiple is 6. So this one already has 6 as its denominator, so I'm going to make 2/3 also have 6 as its denominator. What times 3 equals 6? That's 2. And whatever I do to the bottom, I do to the top. 2 times 2 is 4. So 2/3 is equivalent to 4/6, which is smaller than 5/6. So the next fraction would be 2/3, and the biggest fraction would be 5/6. So that's how we can put fractions in order from least to greatest, and the same thing would apply if you had to put it in order from greatest to least. You would just do the exact same thing, but go the other direction. I hope this math lesson made sense to you. Go ahead, do your very, very best on the quiz, which is attached beneath this video inside the Math Google Classroom, and I will catch you next time. This is Mr. Dauber, signing off.